performance test for single cylinder. So this is performance test calculation. First, what you have to do is, first step is to find brake power. Brake power is equals to 2 pi nt by 60. So from the table, so brake power, this is one formula. Again we have one more formula, which is V into I by 1000 into generator efficiency. So this is the formula you have to use. So this is for mechanical loading, this is for electrical loading. Since we are doing for electrical loading, we'll be using this brake power. So for our calculation, we'll be taking the second calculation, which is V is equals to 230 volt, and current we got to be 2 amps. So I'll be getting my efficiency, like brake power is equals to 230 into 2 divided by 1000 into generator efficiency, probably 88%. So we'll get the brake power. Okay, note down this value. Then we'll be finding fuel consumption per hour, which is equals to, so 20 cc you got, right? 20 cc into 3600 into density of fuel. So like specific gravity of the fuel is 0.83 divided by time taken for 20 cc. So that already we have taken. In this case, it is around 141 seconds. So this is 141.6 seconds. So if I substitute this, I'll be getting the fuel consumption per hour. So like this we have to do for all the values. So 0 amps, 2 amps, 4 amps, 6 amps, 8 amps. So like this for everything we'll be doing the calculation. Then what you have to do is, you have to draw a graph between fuel consumption per hour and brake power on x-axis at the middle. Like if this is the graph means, so central you have to take. So from here, so accordingly for first one, brake power will become 0, but there will be some fuel consumption. You note down the value. Similarly, for different brake power values, you will get a graph like this. So you connect this value and you have to take the slope of this. So where it is intersecting with y-axis, so that will be your frictional power. So it should be, so the maximum brake power will be around 2.5 kilowatt. So the friction power should not exceed 30% of maximum brake power. So it will be around 0.7 kilowatt. So if it is exceeding, you just take 0.7 kilowatt. So then this is your brake power. Then we have another thing which is called as brake specific fuel consumption. So this is our third thing, BSFC, which is fuel consumption per hour divided by our brake power. So this will give you brake specific fuel consumption. It means that for generating 1 kilowatt of brake power, how much of fuel is consumed. So that is what is BSFC. Then fourth one is your indicated power. Indicated power is equals to fuel brake friction power plus brake power. And fifth one is your thermal efficiency, which is equals to brake power into 3600 divided by fuel consumption per hour into calorific value of fuel. Calorific value of fuel is 42,000 kilojoule per kilogram. So once you substitute, you will get the value of brake thermal efficiency. So next is mechanical efficiency. Mechanical efficiency is simple, it is brake power divided by indicated power. So all these things will be coming in percentage. Then finally what you have to do is, you have to if possible, you plot a graph like this. So take the brake power in the x-axis, and you'll take BSFC, then thermal efficiency, mechanical efficiency on the y-axis. So these three things. So you'll get brake fuel consumption power like this. So brake BSFC versus brake power will be like this, and mechanical efficiency and thermal efficiency will be like this. Mechanical efficiency versus brake power, and this one is thermal efficiency versus brake power. So you'll get a graph like this. That's it.